Hello and welcome to the Project Spotlight series here at the Centre for Excellence for Data Science, Artificial Intelligence and Modelling. And I am joined with a wonderful MSc project student here. Would you like to introduce yourself?
Yes, thank you so much for having me. And hi everyone, my name is Grace Udo. I just recently concluded my master's degree in AI and data science in University of Hull, and I'm here to shed some light about what I did for my final project.
Excellent, that's brilliant. So I guess the first question we can start off with is what inspired you to actually choose this project for your MSc?
Well, Lawrence, that's a very interesting question. Well, when I came across the project topic initially, I thought to myself, over my years of studying human physiology at the bachelor's level, I never thought about preeclampsia in the light of the cellular activities that underlie it. And then imagining how AI and data science can be applied to it was so amazing, and I needed to explore it. So after the first meeting I had with my project supervisor, she told me about her experience with preeclampsia. As gory as that was, I had to empathize with her. It was clear that her symptoms were immune dysregulation related. And then I thought to myself, is it possible that unsupervised learning can be deployed in discovering the early causes of preeclampsia? Because preeclampsia is a health condition that is always detected late or a post-delivery affair. And can it uncover nuances or what underlies it for the early detection? And then I thought to myself, okay, let's figure it out.
Wow, so that's quite an interesting root cause for you deciding this, and it seems like a very, very cool and inspiring reason to actually follow such a project.
Right. Yeah.
Well, that's brilliant. Can you give us a brief overview of what the actual project involved?
Yes, the real gist of the matter is that during pregnancy, the mother and the baby requires some level of immune balance, you can say homeostasis, for the mother to be able to take that pregnancy to term. Now, preeclampsia is known to distort this balance, and it presents with so many symptoms that are associated with it, like high blood pressure and the rest. Now, my project aims to resolve this or fill the gap in the areas of late detection of preeclampsia by developing, implementing, and evaluating a, I'll say, comprehensive unsupervised learning framework, which was applied on high dimensional set of data to uncover immune subtypes or subgroups associated with early to mid pregnancy and the preeclampsia that occurs within this time, or to identify preeclampsia at the early stage, essentially. And to achieve this, I set out to do three things. I'm just going to summarize my objectives into three key points. Was to integrate three different approaches to unsupervised learning clustering. One would be a centroid-based approach, a graph-based approach, and a density-based approach. Also was to implement and evaluate two approaches to dimensional reduction, because the kind of data I used was site-of data, which is very high dimensional. You can imagine, what that is like to dig into what the data really has to offer. So was to use two different approaches and then assess or evaluate their impact on the cluster performance and the quality of the clusters and the immune or cell type subgroups that would be uncovered. And then finally was to do a comparative analysis across gestations, or when I say gestations, I mean the trimesters of pregnancy.
Right.
So across the trimesters of pregnancy, evaluating or comparing the control group of pregnant women, those are the pregnant women that didn't have preeclampsia, to those who had preeclampsia, to see what is in one that wasn't in the other in terms of immune subtypes and subgroups for the early detection of preeclampsia. So that's essentially what my project's overview is about. I used secondary data from 45 pregnant women. I do not know where they're from, their ethnicity, but yes, it was a combination of women who had preeclampsia and women who didn't at the time of pregnancy. And all in all, I worked with about 230,000 cells.
Wow. Okay,
Yeah.
it's quite a lot. So, okay, so you used some AI and data science techniques. I heard you mentioned with clustering, for example. Can you just give us elaborate some more as to how you use these in the work itself?
Yeah, absolutely. Yeah. So as I initially mentioned that I wanted to integrate 3 different approaches to unsupervised learning clustering. But before I did that, I deployed dimensional reduction techniques because of the kind of data I was using. I first deployed a linear dimensional reduction technique, which my choice was principal component analysis, PCA. And then secondly, I deployed a nonlinear dimensional reduction technique, also called uniform manifold approximation and projection, also called UMAP. And this was a prelude step before I implemented my clustering algorithms. I used 3 different clustering algorithms, K-means, which is centroid based, like I initially mentioned I was going to use, HDB scan, which is density based, and phenograph, which is graph based. And I evaluated with, you can say, traditional unsupervised learning evaluation metrics like the silhouette metrics, David Boolean, Kalinski-Harabas. I struggle with pronouncing that. So from now on, I will be saying CH. Yeah. So the reason why I chose K-means was that I felt it would be perfect for identifying immune subgroups. Why? Because it distributes cells, or you can say data points, to different clusters, and every cell is very similar to its mean. So let's say a cell has CD3, CD4, a high population of CD3, CD4 in one cluster. It's clear that that cluster is T cell-ish because it's similar to its mean. So it would have been, for me, when I was thinking, it would have been the perfect algorithm to choose or to identify immune subgroups. Then I chose HDB scan as the choice because, first of all, it's a development from DB scan. It's free from the limitations that K-means and DB scan has. For DB scan, it doesn't struggle with the limitations of the epsilon radius. And for K-means, it doesn't have to be forced to be a spherical shape in terms of the data shape structure, the data point structure, and every data point is a core point of its own. So I thought, yes, let's use HDB. Additionally, for phenograph, to be honest, the reason why I chose phenograph was because, firstly, I wanted to have different approaches so my work can be more robust. However, many researchers praise phenograph. Many CyTOF researchers, people who use my kind of data, praise phenograph as being the ideal for the kind of data I was working with. It's Jacquard similarity based. It works with unions and sets in a community of data points, and it also uses Louvain. So I decided to implement those.
Excellent. That was a very in-depth answer. I really appreciate that. It's really lovely. Well, that's great. It's a very in-depth answer. So with that in mind, what were the challenges you actually faced, if any, during your project?
Do you want to take a guess? I'm joking. But you'll be surprised or not that I faced challenges with phenograph, the algorithm that came very much praised by CyTOF researchers. And I really struggled with it because it gave results like this.
Oh, wow.
So the clusters were too fragmented, too fine-grained. I had issues around the comparison analysis of gestations and comparing the control group to the preeclampsia group because it looks like an amalgamated map.
Yeah.
So it was really a struggle with it. Let me show you something else. So this is a cluster mess, if you ask me. One would really struggle to gain insights from 30-something clusters. So I found it really terrible. And apparently I wasn't alone in the struggle, because other researchers, although they don't write that in their research report, use something called post hoc meta-clustering, which is a thing, actually. I had to find that out the hard way when I went to a community to cry out my heart. I am struggling with phenograph. And people use a post hoc clustering aggregation to solve this issue.
Wow, okay. But that's great. So you use the literature to help solve your problem.
Yes.
So, I mean, and the help of the research community involved. So that's excellent. And what you should do as a researcher, I would argue. So how do you think your project could impact real-world problems then? I guess we can allude to how this could help, but what would you say?
Yeah, absolutely. It can, in real time, solve real-world problems, especially in the clinical and research sphere. I'm just going to sweep out some parts of my pipeline to tell you how they answer real-time issues. So for K-means, K-means is population-based in that data points are assigned to different clusters, and whatever is similar, data points that most similar cluster up in the cluster they are similar to. If you compare the control group versus the preeclampsia group, those slight changes that are noted can be used to inform and improve the current immunological ranges that can inform testing, especially for women who might be most at risk at having preeclampsia. In addition, an algorithm like HDB does more than identify subgroups. It says, I am a cell type and I'm doing something. So it says what the biology of these cells are basically doing. Is it activated? Is it transitioning? Is it a rare type of occurrence? It points to clinicians on where they should research or what they should test for. Now, for phenograph, I feel it will be very, very helpful to researchers if they are focusing on lesser amount of cells. They can zoom in to what the nitty-gritty is saying, because this is what they might get. Right. So they can zoom into the fine details and gain real-time insights to inform preeclampsia-related research.
Excellent. Okay. So with that in mind, I guess, were there any, obviously there were some issues that you came across, but were there any surprising findings or insights that emerged from the work that you did? Yes,
actually, I did have some really surprising findings. And it was how my dimensional reduction techniques influenced the outcome of my results and the quality of my clusters. As you can see here, pipeline 2 being UMAP based, non-linear dimensional reduction based, outperformed pipeline 1, which is PCA based, across all algorithms, HDB and phenograph. We're looking at in all the evaluation metrics, they all did better. Higher silhouette scores, lower DB scores, higher CH scores across board. So that was very interesting to know. Another thing was how my experience with HDB scan was with looking at both dimensional reduction techniques. You can clearly see that I struggled to get a cluster or two using PCA, and you can obviously see well-separated clusters identified with UMAP and little to no noise. So the reason this happened was because PCA draws an axis towards where the data point has most variance. So and it projects on that axis and gets essentially what is in that data set. However, UMAP has a way of creating a graph so that all data points and their nearest neighbors can be connected. So it connects the entire data set. My data set was very fuzzy, by the way, very overlapped and interlocking, but wherever you are OE data, UMAP will find you. And that was why I got, better results with UMAP. Another thing that I got was, the performance of my algorithms altogether. To be quite frank, I do not like to, my project wasn't to say which algorithm outperformed which. It was supposed to be an integration of 3, all having their own moving parts. However, I would say K-means and HDB performed best compared to Phenograph. And the reason why Phenograph performed poorly, even though in PCA you can obviously see a lot of overlapping here.
Lots of clustering.
Yeah, and it did better with UMAP, but scored lower through the lens of the evaluation metrics. The reason that was because, come and look at this. There's no separability in this at all. And the compactness is there. However, DB is going to look at one cluster and another and think it's the same thing.
Yeah.
So there's that. Then other researchers say that because of the Jacquard nature of Phenograph, there's a tendency that it's not going to obey the laws of the Euclidean principle, which HDB and K-means obey. Right. So that's those are some of my discoveries that are AI and data related based.
That's super interesting, actually.
Yeah.
I think. So I guess you've done this work here, but how would you take it forward in the future? What would be the next steps? How would it evolve for future work?
Yeah, absolutely. So I imagine my pipeline or my framework being more fine-tuned with more diverse data from people of different demographics, people from lower income communities of different ethnicities, getting all of that kind of variety in data can improve what I already have going on. I also believe that beyond just preeclampsia, if this pipeline or if this framework is well improved, it can be a plug and play for immune dysregulation detection. That's what I feel, and can be applied in other areas such as cancer research, research around autoimmune diseases, and also can be used with other kind of data sets like single cell data or other metadata can be used to inform its robustness, like the age of the mother, her BMI and the rest. So I imagine it being improved in the future to be a plug and play immune dysregulation detector tool.
Excellent. So a very useful thing for the medical community, hopefully.
Yes.
And for the condition that is obviously afflicting those women.
Yeah.
So what advice would you give then to future MSc project students when they begin their project?
Do not undermine your weekly meetings with your project supervisor. All because it helps. First of all, it helps you keep the streak, because when you're not having classes, you might want to slack a bit. And then secondly, it always just helps you with your problems. For me, it shaped my perspective on what to do and how to do it. Even though my project supervisor, Eva Sosa, wasn't, handing it over to me, she would say, why not look at it at this, towards this perspective. And that was really helpful for me. Also, I would say, spread your tentacles, get information, join communities. For me, it was the Stanford Edu site of community that I went to cry out my heart about Phenograph that saved me. And then also, you read a lot of research papers because you would find them really useful for your project.
Okay, well, that's excellent. So how's the MSc project that you've done here, how has that shaped your future career aspirations in AI and data science?
Oh, it has very greatly, because prior to when I started the program, or rather the MSc project, I never knew that there were roles like computational immunologist or computational biologist. In fact, I had no clue until I explored the project to figure out that there are researchers, clinicians who have given years of their life's work to focusing on this kind of research, or working with this kind of data in the sphere of AI and machine learning. So I think I found my niche. Thanks to the project, I found my niche, and I would like to stay here for a while. So yeah, it has helped me a great deal in forming my career trajectory.
Oh, that's excellent to hear. It's always nice to see when people get an inspiration from the projects that they do.
Yeah.
And you get that help from the supervisor as well along the way. I guess finally, if you could expand on your project into additional areas, would you? And what would you go into? Would it be further medical stuff, or would you branch out somewhere else?
Well, still within the medical sphere. If I were to improve on the project, or I would try to solve the issue that I had with my limitation with phenograph, I would explore the post hoc aggregation clustering. I was recommended Flowsome, which is an algorithm that does that seamlessly. So I would explore that because I want to tie every knot to ensure that my work is properly done. Also, Aside that, I would like to integrate some predictive models to my work. Let's say unsupervised learning and deep learning, because I feel like it will make the analytical framework more practicable for researchers and clinicians, but mostly clinicians, because they're the ones who would be working with patients directly to help, provide the right intervention for them. Yeah, so I would try to make my work more robust using these predictive models, hoping that they'll be well trained enough to detect even the slightest change in immune dysregulation. Yeah.
Excellent. Well, thank you very much, Grace, for your time and giving us some insight into the project work you've done alongside us. And we hope the best for you for your future and your career aspirations.
Thank you so much, Lawrence.
No, you're welcome. So that's the Project Spotlight series for today. Thank you very much, and bye for now.